This presentation is about exact trig ratios. Grade E students will be able to use a calculator to find exact trig ratios. Grade C students will be able to remember exact trig ratios. Grade A students will be able to prove exact trig ratios. Section 4. Exact trig ratios. Page 10 of the C2 notes. The first trigonometric table was apparently compiled by Hipparchus, who is now consequently known as the father of trigonometry. Sumerian astronomers introduced angle measure using a division of circles into 360 degrees. Then their successors, the Babylonians, studied the ratios of the sides of similar triangles and discovered some properties of these ratios, but did not turn that into a systematic method for finding sides and angles of triangles. The ancient Nubarians used a similar method. The ancient Greeks transformed trigonometry into an ordered science. Exact trigonometric ratios are used to enable trigonometric calculation without the use of a scientific calculator and is particularly useful to the field of physics, where they can be used to resolve forces in mechanics. The exact trig ratios of sine 45, cos 45 and tan 45 degrees can be found from the isosceles triangle with equal sides 1 and angles 45 degrees at the edge. This makes the non-equal angle equal to 90 degrees, a right angle. Now we can use either the 45 degrees to get the ratio that we require. So we're going to use this 45 degrees. Now to get sine 45 degrees we'll need to know the length of the hypotenuse. From Pythagoras' theorem, 1 squared plus 1 squared equals the hypotenuse squared. So the hypotenuse squared is equal to 2. So the hypotenuse is equal to the square root of 2. Now sine is equal, from Socator, sine is equal to opposite over adjacent. So for our 45 degree angle, sine is equal to opposite over the hypotenuse. So the opposite side is 1, the hypotenuse is root 2. So sine 45 degrees is 1 divided by root 2. And in rationalised denominator form, root 2 over 2. Cos 45 degrees, well the adjacent side is also 1. It's over the hypotenuse, which is root 2. So cos 45 degrees is also equal to 1 over root 2, or root 2 over 2. Tan 45 degrees is equal to the opposite side over the adjacent side, which is 1 over 1, which equals 1. Our second triangle that allows us to find exact trig ratios is the equilateral triangle with all sides equal to 2. And what we do is we divide that triangle exactly in half to make two right angled triangles. The length of the bottom side will be half the total side, so that will be length 1. The angle at the top will be half the angle of 60 degrees, which is 30 degrees. Again we have a missing side, but it's the hypotenuse we have this time. So our missing side can be found by doing the square root of 2 squared minus 1 squared. Which is equal to the square root of 3. And again we use Socator to find our exact trig ratios. So sine 30 degrees, when we get our 30 degrees, the opposite side is 1 over the hypotenuse, which is 2. Cos 30 degrees, the adjacent side is root 3. Over the hypotenuse, which is 2, and tan 30 degrees is the opposite side, which is 1, over the adjacent side, which is root 3. Rationalising, we get root 3 over 3. Sine 60 degrees, go from 60 degrees, the opposite side is root 3 over the hypotenuse, which is 2. Cos 60 degrees, the adjacent side is 1 over the hypotenuse, which is 2. And tan 60 degrees, the opposite side is root 3 over the adjacent side, which is 1. So tan 60 degrees is equal to root 3. It's recommended we put all of this into a table, which is in the back of the booklet. So our degrees, the key ones are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. The corresponding radians, which we'll deal with later in the course, are 0 radians, pi over 6, pi over 4, pi over 3, and pi over 2. Now, a quick way of reconstructing this table from memory is that sine of 0 degrees is 0 over 2, sine of 30 is 1 over 2, square root of 0 over 2, square root of 1 over 2, 45 degrees is root 2 over 2, pi over 3 is root 3 over 2, and pi over 2 is root 4 over 2. First one just simplifies to 0, the second one simplifies to a half, the middle one is equivalent to 1 over root 2, root 3 over 2 is the correct form, and root 4 over 2 is equal to 1. And then the cos row is just the same but in the opposite order. So cos of 0 is 1, cos of 30 degrees is root 3 over 2, cos 45 degrees is root 2 over 2, or 1 over root 2, cos of 60 degrees is a half, and cos of 90 degrees is equal to 0. And then we use an identity, which we'll cover later in the course, that tan is equal to sine divided by cos. So for 0, 0 divided by 1 is 0. (30 degrees) a half over root 3 over 2 is 1 over root 3, or root 3 over 2, root 3 over 3, sorry. 45 degrees is 1 over root 2 over 1 over root 2. Which is 1. (60 degrees is 3 pi over 2 divided by a half. Basically the other way around to 33 degrees, so you get root 3 over 1, which is root 3. And for 90 degrees we get 1 divided by 0. You can't divide by 0. Now some people would say that that was equal to infinity. Though in practice it's better really to say that tan of 90 degrees is undefined, so there is no answer for that value.